Hi, my name is Rishi and I'll be talking about direct and inverse variation. So, what is variation? Variation is the relationship between variables in algebra. It helps to see how two unknowns relate to each other. So first off, we're going to start with direct variation. So, direct variation is when the change in y is the same direction as the change in x. So in other words, when x goes up, y goes up. Or when x goes down, y goes down. With direct variation, there are some formulas that we use. The most common one is y equals kx. Now, y equals kx, what does this mean? Well, x is our input, y is our output, but what is k? K, in both direct and inverse variation, is equal to our constant term. So it's the term that stays the same. It doesn't change, it's not a variable. Now, some other common ways to write direct variation, but you're probably not going to see them as much, are y over x is equal to k, and f of x is equal to k times x. Now, let's move on to inverse variation. So, inverse variation is when x goes down, y goes up. So we have inverse variation, and that's when the change in y is different than the change in x. So they go in different directions. When x goes up, y goes down. And when x goes down, y goes up. Now the formula we use to represent inverse variation is y is equal to k over x. And remember, k is our constant, x is our input, and y is our output. Some other common formulas is x is equal to k, and f of x is equal to k over x. Now, this might be a bit confusing at this point because we haven't really worked with any numbers or real word problems. So let's work with some real life scenarios. So here's our first word problem, and let's work through it together so we can get some sense of what inverse and direct variation really is. So Benji's doggy daycare charges $30 a day. So that is our first rate, because it's some amount or some value over time. Now, if Benji stays for more days, so days can be represented by the variable d, what will happen to the price? And price can be represented as a variable p. So, with these three pieces of information in mind, let's see if it's direct or inverse variation. So, y equals kx is direct, and y equals k over x is inverse variation. So now, let's see which one suits this problem more accurately. Well, $30 a day is our fixed rate. That number is not going to change. And remember what we said earlier, our fixed rate is called a constant. And that constant is also called k. So in both of these equations, let's put y is equal to 30 times kx. So y is equal to 30 over x for our inverse variation. Now, let's work through a few scenarios and see what happens when we change the value of x. We'll use the values 1, 2, and 5. So, if d is equal to 1, if Benji stays for 1 day, then y will be equal to 30 for direct variation, and y will be equal to 30 for inverse variation. If Benji stays for 2 days, then y will be equal to 60 for direct and 15 for inverse. So already we see a pattern. When x goes up in the direct variation, so as x was 1, y was 30. And in that scenario, that was our first scenario, so we're not really going to see any change. But as we look at our second scenario, when x is 2, y is 60. So they both went up. X and y both went up. It's the opposite for inverse variation. When x was 1 and y was 30, x became 2, so x became greater, and y became smaller. It went from 30 to 15. Now, logically, let's see what makes more sense. If Benji stays for more days, will he have to pay more or will he have to pay less? He'll have to pay more, right? So we want to go with the option that when x goes up or when d goes up, y goes up. And y is also our price. So we can see that the change in d is the same as the change in p. They're both going up, which means that this problem is indeed direct variation. So now, we know that y represents price. This is direct variation, but let's do one last part of this problem. So, how much will the daycare cost after 5 days? Well, we know that y is equal to 30d, or in another way we can write it is p is equal to 30d. Now, if Benji stays for 5 days, so if d is equal to 5, what will be p? Well, we can just substitute d, or 5, into the equation for d. So, p is equal to 30 times 5, and therefore p is equal to $150. So now we've answered all 3 questions. We know that y represents price, or output is price. This is direct variation, and it will cost $150 after 5 days. So now let's move on to another problem. Okay, so this is our next word problem, and let's work this out the same way we worked at the first word problem. I have 36 slices of pears and some guinea pigs. Each guinea pig will get the same number of slices. What will happen if the number of guinea pigs increases? Well, let's first map out our problem and determine our variables. P is equal to the number of slices of pears. Each guinea pig will get the same number of slices. So, we can use n to represent the number of slices. And finally, what will happen if the number of guinea pigs increases? So we can use g to represent the number of guinea pigs. And I'm going to specify for n, it's the number of slices per guinea pig. Now we have to determine which of these values is our constant, or k. Well, it says that I have 36 slices of pears, and that value isn't going to change. So we know that p is our constant. So instead of saying p equals slices of pears, we can say k equals the slices of pears. And to be more detailed, number of slices of pears. Now, let's use both equations and see which one fits best. We have y equals kx and y equals k over x. Well, in this problem, our k, our constant, is 36. So instead of saying k, we can write 36. Now we have to find our x, or our input variable. So what variable are we voluntarily changing? Well, we are changing the number of guinea pigs. So that is our input, or we can also call it an independent variable. So if x goes up, what will happen to y? So we have a question mark here. Well, let's try a few values and see what happens. We'll use 1, 12, and let's use 4. So, for the first value, we have x equals 1. So y equals 36 here, and y equals 36 here. So for direct and inverse, they're both the same. But now, if we have x is equal to 12, let's see what happens. For the inverse variation, we have y is equal to 3. And for direct variation, we have y is equal to 432. So with our inverse variation, you can see that as our x value went up, our y value went down. So here it was 36, here it was 3, and when we do it with the 4, so when we use 4 as x, we'll get y equals 9. And for our direct variation, we'll get y equals 144. So here was 9. I'm just going to fill out the rest of this table. So you can clearly see the relationship between inverse and direct variation. Now, let's see which one logically makes more sense. If we increase the number of guinea pigs, will each pig get more or less slices? Well, if we have the same number of slices and we increase the number of guinea pigs, then we're dividing our constant value by more. And therefore, the number of slices per guinea pig, or G, will go down. So as x goes up, y goes down. And this is a problem to do with inverse variation. So we've determined that this problem has to do with inverse variation. Okay, so now we know that this problem has to do with inverse variation. Let's solve one more part. How many slices of pear will 2 guinea pigs get if I have 2 guinea pigs? Well, now that we know it's inverse variation, we can write our formula up here. Y equals 36, or instead of y, let's use g, because g is our number of guinea pigs. So g equals 36 over, and the number of guinea pigs is 2. So, I'm sorry, we shouldn't use g, we should use n for our output. And our number of guinea pigs is 2. So therefore, n is going to be 18. So the number of slices per pig is going to be equal to 18. Alright, that's it for this video, direct and inverse variation.